Alright, thank you for joining us. In today's video, we'll be doing a walkthrough of a test paper in which it has a section 1 and 2. And the first question, in which this is seen in most CXC type questions, it says using a calculator or otherwise, we're to calculate 3 and 3 over 8 subtracted from 2 and 1 over 4, all divided by 1.5. Alright, so we know that there are several ways we could do this, but the safest way for us to do, and we're going to give our answers in a fraction in its lowest term. So we're going to convert this into an improper fraction. In order to do that, we know we multiply the denominator 8 by the whole number, then we add that to the numerator. We'll put that answer over our denominator. So 3 times 8, 24. 24 plus 3 give us 27 over 8. We're being subtracted by 2 times 4, 8 plus 1, 9. That is 9 over 4. So in subtracting two unlike fractions, because we realize that the denominators are different, we're going to find the LCM of both. And we realize that we can use 8, because 8 can go into itself and 4 can go into 8 without leaving a remainder. Alright, so we're going to do that, and then we're going to subtract the numerator. So 8 into 8 goes 1 time. 1 times 27 goes 27. Subtracted from 4 into 8 goes 2. 2 times 9, 18. And what we get here, we get 27 minus 18. And that will give us a 9 over 8. Alright. So all of this was being divided by our 1.5, which is 2 times 1, 2, and 1, 3. 3 over 2. So what we had right here would be the 9 over 8, and this will be divided by 3 over 2. Alright, so seeing that we have 9 over 8 divided by 3 over 2, we can find the reciprocal of that and change the sign by saying 9 over 8 multiplied by 2 over 3. Alright, with that said, now we know we can do some easy cancelling because we see these are multiples. So 2 into 2, 1, 2 into 8 goes 4. 3 into 3, 1, 3 into 9, 3. And our answer will be 3 times 1, which is 3, and 4 times 1, which is 4. Alright, so we're going to move on now to our second question, question B, which says write the value of 12.8 squared minus 30 divided by 0.375. And we see two brackets. And what we see for this first bracket, we see that the square is being affected by the bracket. So it's 12.8 all squared. So we're going to say 12.8. We're plugging that in our calculator. We know we can just multiply it by 2. And so this section of the bracket would be equal to 163.84. And then when we subtracted 30 divided by 0.375, we will get 80. All right. So in 163.84 minus 80, the complete answer at the exact value would be equal to 83.84. All right, and that is our exact value. So write this answer now to two significant figures. So in writing a number to two significant figures, we write the number that are after the decimal places, right? Or we see, in taking our reference from the decimal point, we see these are two numbers, right? So in writing them to two significant figures, we're going to also look on the number after the decimal place, which is 8. So if it's less than 5, we let the number remain, but if it's more than 5, we add 1 to the number. So because after the decimal place at 8, we're going to round this up to 84. Right, and that is to two significant figures. In our writing our answer, and this is not what we should write in standard form, so our answer is 83.84 in standard form. And what standard form is raising a number to a power of 10, and then when we do that, we're going to use one digit, which is between 1 and 9, that when we multiply that number again, we can get back the same answer. What we realize is that we see this 83 is raised to 10 to the first power, right? So we know if we move decimal place 1 point right here, we see a number that is between 0, 1, and 8. So we can have 8.384 times 10 to the first power. And when we raise this to the first power now, it will give us back the 83.84. That would be our answer for that question right there. All right, in our question C, it says the table below shows a shopping bill prepaid for Mrs. Rowe. The price of some items are missing, right? So we know that 3 kgs of sugar cost X prices, and we know that the total would be for $10.80. 4 kgs of rice will cost Y dollars, and we want to find out what would be the total. Then we know 2 kgs of flour the unit price is $1.60, and the total is $3.20. All right, so with that said, what we need to calculate is the value of X to find the cost of 1 kg of sugar, right? So we know that the cost on kg of sugar, that would be equal to 10.80 divided by 3, right? Because what we realized that what we purchased was 3 kg, right? So the item that we wanted to find out is what 1 kg would cost, and in all we purchased 3 kg, right? So we're going to divide the total cost by how many items we did. So 10.80 divided by 3 would give us, on our calculators, 3.60. So $3.60 would be the unit cost. Alright. Alright, next we need to find out the cost of 1 kg of rice. What we realize is that the $1.60, which is the cost for the flour, and the $0.80 is, let's say now, equal $1.60. When we divide that now, let's see, divide that by 2, so we get the and we will get all right, so we know that, let's see right now, for rice and the sugars, all right, so we are given a condition. It says if the cost of 1 kg of rice is 80 cents more than 1 kg of flour, we're to calculate the values of X and Y, right? So we know that the cost for 1 kg of flour is $1.60, right? And so what they're saying is that the cost of 1 kg of rice, that would be the unit cost, is 80 cents more, right? So we know 1 kg of flour is $1.60. So they're saying the cost for 1 kg of rice would be 80 cents more. So what we're going to do is the 1.60, we're going to add that to 80 cents, and what we'd get is the 2.4. So the unit cost will be $2.04, right? And 40 cents, rather. So if this is the unit cost, what we need to do now is to time this by 4. We have 2.40 times 4. And we would get equal $9.60. We have a $9.60. Right? So we're given a condition that one of the items, which is the rice, would cost more than flour, And we do know that is true. And they're saying that it's called 80 cents more than the cost for the flour. And so we added the 80 cents to the 1.60. And we add $2.40. And let's move on to the next part of the question now, in which it says the tax of 10% of the total cost price of the 3 items is added to Mrs. Rowe bill. What is Mrs. Rowe total bill including the tax? Alright, so we need to find out what is the total cost. So it would be the 10.80 plus 9.60 plus 3.20. Alright, so the total cost is $23.60, right? And we know that the tax is equal to a 10% tax. Alright, so there's several ways we can look on this, but let's just try to use a tax formula, or we can use even what we do know is that if this tax, which is 10%, we know we're going to add that to the 100, in which it's going to be 110, right? 110 over 100, and will be 23.60. And what we're saying is that, you know, the total bill, it would be out of 100%, but this tax, which is added to your bill, so the total cost would be 110 over 100. When we calculate that now on our calculators, we will get 25.96. 96. Right? We know we could then try to find we could just try to find what is the 10%, in which what we would do is to say the and times 23.60 divided by 100 and alright, so seeing that this 90. Alright, we could just try to find what the 10% is, and then we add it to our $23.60. But in all, we can just add it as, say, 110 over the 100, and our total figure will be $25.96. Alright, let's move on to. Alright, so we're at question number 2, in which we are asked to simplify p to the second power times q to the third power multiplied by p to the first power times q to the fifth power. Alright, so these are indices type questions, and we know that we are multiplying two variables, right? And we see that they have the same base and different power. So what we're going to do, when we're multiplying, we know that we're going to add the power and keep the same base, right? So we have p to the squared multiplied by p to the first power. So it will be p squared plus p to the first power. And we have q to the cube multiplied by q to the fifth. So in all, and all of this is being multiplied, all we will have p to the third times q to the eighth. Alright? That's simple how it's done. Right? We're multiplying them. We see that they have the same base. Being raised to our power, we're going to add the powers and keep the same base. That question is finished. And now this question now, which is a binary type question, in which it says if a times b is equal to 2a minus 5b, we're going to evaluate 3 times 4. And what we see is 3 times 4, we know this would be the a and this would be our b. And so what we're saying is that the a, which is the 3, and the 4, which is the b, we're saying 2 times our a, which is 3, minus by 5 times our b, which is 4. 2 times 3 give us a 6, and 5 times 4 give us a 20. So 6 minus 20, that would give us a negative 14. And that is finished. 1 mark. Alright, similarly now, we know this is a distributive type question. However, we know first here would have this being there A, and the 4 is still our B, but then this one would be our B. So it's a distributive, it's a operation in which we are going to say A times B times this section here would be the A, and this one here would be the B. Even though what we know we have 3 times 4, which is A times B, right? We got this answer already, which is equal to negative 14. The negative 14 times B, which is 1, and that would be equal to, alright, we're still gonna apply it in this formula here. So we're gonna say 2 times our negative 14 minus 5 times this one, which would be our B, which is equal to a 1. 2 times 14, and that would be equal to negative 28. 5 times negative 1, which is equal to negative 5. And a negative 28 minus a 5, that would be equal to negative 33. We know this one right here, in which we had already found the 3 times 4, right? And seeing that it's as a bracket, we're going to treat this as 1. We're still seeing where it's multiplied by a 1. We're going to consider this our B, and we're going to, we know that it's equal to 2 times A minus 5 times B, right? And so if all of this is A, we're going to say 2 times all of this, which is A, minus 5 times all of this, which is B. And we get 2 times negative 14, which is equal negative 28, subtracted from 5 times this one here, which is the B, is equal to 5. All right. That is the question completed. So for this question here, it's a factorizing. And what we see common, we see the 6 common in both these numbers. We see A and we see B, right? In looking at this, we need to then identify what is our highest common factor. So in the coefficients, right, we see 6 and we see 12, right? What is common between those two numbers? We see 6 is the highest number that is common between those two numbers. Looking at the A squared in this one and the A to the 4th power in this one, we see that A to the squared is common in both two numbers. Looking at the B cube and the B to the 1st power, see that's only B that is common. So all of this would be our highest common factor, in which we can multiply our highest common factor by this right here, and we won't get a remainder. So with that said, our highest common factor is 6a squared b, right? 6a squared, when I use our bracket, 6a squared times b multiplied by 6a squared b cube, what that will give us? That will give us just a b squared, right? We don't want to put the 1 for the 6, so we just can say b squared, right? I'm going to add this now to 6a squared times b cube into 12a fourth times b. That will give us 2a squared. Yeah, and that's a squared. All right. And so what we realize is that if we have 6a squared times b squared, we get back our 6a squared b cube, and 6a squared b times 2a squared will give us back the 12a to the 4th b. And that is what we needed to do to factorize what is the highest common factor in both these two terms, and then we could factorize them completely. For this type of question now, we see that this is a perfect square, right? Because we know that the 9, that is a number that we can find a perfect square of that. We know 4 as well, so we can find a perfect square. So let's try to just break up the 4a square, right? And what we can do to factorize that, we know that it is equal to 2a times 2a, right? That will give us 4a squared. And we know 9, we can say 3, a negative 3 times a 3, and that will give us a 9, right? So with that said, we can say now the difference of 2 squared would be equal to 2a minus 3 and 2a plus 3, right? 2a times that give us 4a squared, negative 3 times that give us 9. And that would be the answer right there. All right, for our next question, it says the height h of an object is directly proportional to the square root of its perimeter. P. Write an equation showing the relationship between h and p. All right, so we know that this is a direct variation question in which we are saying, what are we saying? We're saying h, which is the height, is directly proportional to what? The square root of p. And that is somewhat the relationship, right? However, we know that for direct proportional, there is a constant. So our constant, which is usually represented by a letter k, right? K times the square root of p, right? So we know whatever our constant is times the square root of p will allow the equation to be directly proportional. And for the second part now, we are given that h is equal to 5.4 and p is equal to 1.44. Determine the value of h when p is equal to 2.89. All right, so we know that in this we need to first find our k, and then they change the value of p. So we're going to find the value of k first, and then with that said, we can find what p will, what k will be, what h will be when our p is changed to a 2.89. Finding k. All right, so we know that h is equal to k times square root of p. So now our h in this case is equal to 5.4, and our p is equal to 1.44. All right, and we know really if we remove the decimal point from this number, it would be 144, right? So we know we can find the square root of 144. Hopefully that's a number that is easy to identify. We know that it would be equal to 12, right? So we can say 1.2. With that said, now we have one unknown, and we see over this side it is being multiplied. In order for us to make k the subject or to solve, we need to do the opposite of this multiplication, which is to divide by 1.2. So let's keeping our k equal 5.4 divided by 1.2, and that will be equal to 4.5 is equal to k. So we find our constant now, and what we can do, we can apply it into the function with our new value of p. So in rewriting the general equation for this, we need to say that h is equal to k, which is 4.5 times the square root of p. So, and this is us rewriting it in the general equation. With that said, now we want to find h, and we know that our p is equal to 2.89. So we're going to say our k, which is equal to 4.5 times the square root of our p, which is equal to 2.89. So in finding the square root of 2.89, I guess that's also 289, it would be equal to 4.5 times 17. Right? We know 17 square would give us 289, so the square root of that will be equal to 1.7 rather. And so our h will be equal to 4.5 times 1.7, which is equal to 7.65. And that is how we would find our h with our constant, right? And so if the question gave us another section in which it changed the value of p again, or it changed the value of h, we could still find it because we knew our constant. And as we see, we'd still apply our constant in both the questions. All right, so we see this question. It says the relationship between kinetic energy, E, mass, m, and velocity v for a moving particle is equal half mv squared. And this is the correct kinetic energy formula, right? But in this, we are going to make v the subject, right? So we're going to do a transposing. In order for us to transpose the v squared, the first step that we'll be doing is, as we're seeing right here, we see the m is being multiplied by the v squared, and we see that. So what we need to do is to multiply, let's see here. You see that equal mv squared we're gonna times just rewrite the formula E equal half mv squared, right? We see that the half is in the denominator, so the first thing we're going to do is to multiply this by 2 to get rid of the half in the denominator, right? We have 2 times e will equal 2e is equal to mv squared, right? And what we did was to remove the half, because the half would be giving us a fractional term, so we times it by 2 to get rid of the fraction, and so it's 2e is equal to mv squared. Alright, so we see this is being multiplied. So what we can do now, we can then divide through by the m, because we really want to make the v the subject. So we're going to divide through by m. Alright, and so we have 2e over m is equal to v squared. Alright, and so now that we have the v squared, in order to remove the square, we can square both sides. I find the square root of both sides. Right? And when the square root, when we square root both sides, it will remove the square. So we'll have the square root of 2e over m is equal to v. Right? And the square root will remove the square signs, and then we will have v is equal to square root of 2e divided by m. And that would be our formula. However, so with that said, I'm going to rewrite it. So v is equal to square root of 2e over m. It gave us a value for, it wants us to find the value of v when our e is equal to 104 and our m is equal to 13. So v is equal to the square root, our e is equal to 104, and our m is equal to 13. V is equal to 2 times 104 divided by 13, we get 16. So we say v is equal to the square root of 16. And the square root of 16 would be v is equal to 4. Alright, so that would be our value of v in that equation right here. In this question now we're going to determine, we're given 3 functions f, g, and h, and they're defined as f is equal to 2x minus 1, g of x is equal to 3x plus 2, and h of x is equal to 5 to the x. We're going to find f of a half, right? Half x, f. So what we're saying is that f of x is equal to 2x minus 1. We're going to find f of a half. Alright, so we're going to substitute our x to be equal to a half. So we're saying 2 times a half minus 1. 2 times a half will be equal to 1 minus 1. And 1 minus 1 is equal to 0. So f of a half is equal to 0. Alright, so we're going to find h of 0 now. So what we're saying is h of x is equal to 5 to the x. And h of 0 is equal to 5 to the 0. And 5 to the 0, you know, this is a common indices law. A number raised to the 0 power is equal to 1. Alright, and we're going to find, so this now is, it's a composite type question in which we're going to find g squared, and then when we find g squared, we're going to times it by g to the negative 3. We're going to find what is g squared to the negative 3. So what we need to find is, given that we have g of x is equal to 3x plus 2, we are now going to find g negative 3 is equal to 3, and our x is equal to negative 3 plus 2. This is equal to a negative 9 plus 2, and this is equal to a negative 7. Alright, and with that said now, So we substituted that. We're going to know, after we find our g of negative 3, we're going to apply it now back into g. And we are going to say, alright, so we're going to have g of x, which is equal to 3x plus 2, right? So if we find the second prime of g of x, it would be equal to negative 7, right? And so we're saying equal 3, negative 7 plus 2 equal to 3 times negative 7 is a negative 21 plus 2 equal to negative 19. Yeah. Cool. All right, so as we have here, we're going to find g of f of x, given our answer in the singlet form. So what we know our g of x is equal to 3x plus 2, and our f of x, which is equal to 2x minus 1. All right, so we know that this is our composite function, and the function that we have on the inside, which is our f function, right? So in finding g of f of x, we're going to write our g function, and the x value, whenever we see x, we're going to substitute the function f of x into that function, into the g function. So we see our x, so we're going to substitute the f function, which is 2x minus 1 plus 2. Right? So we see the g function on the outside, which is 3, and this is our x plus 2. We see our f function on the inside, right? And so we're going to substitute it, right? Now we're going to solve to find our g of f of x, which is equal to 3 times 2x, that gives us a 6x, minus 3 times a negative 1, negative 3 plus 2. And so our g of f of x is equal to 6x, negative 3 plus 2 is negative 1. And that would be our g of x in its simplest form. Alright, so we're going to find now g inverse x, right? So we have our g function, g of x is equal to 3x plus 2. Alright, in order to find the inverse of any function, we need to define the function as it relates to y. So we say y is equal to 3x plus 2. Now that we define our function with respect to y, we're going to interchange the values for x and y. Where we see x, we change them to y. Where we see y, we change them to x. That said, this will be our step 1. Alright, to define the function. Our step 2 will be to interchange the variables. We have x is equal to 3y plus 2. Now that we interchange, we're going to solve for y. Alright, we're going to solve for y. So with that said now, we have we have the x right here. In order to make y the subject, what we see a 2 being added to this side. So what we can do is to subtract 2 on both sides. Equals 3y plus 2 minus 2, right? This 2 would be cancelled. So we have x minus 2 is equal to 3y. So rewriting this, we have x minus 2 equals 3y. What we see now, the 3 is being multiplied by the y. So we're going to do the opposite of that, which is to divide through by 3. And so we have x minus 2 over 3 is equal to y. And we see that y is the subject now. And we can then now, in writing it in terms of g of x, we need to rewrite it back. G inverse of x is equal to x minus 2 over 3. That would be our final answer. Right? It says now, hence or otherwise determine the value of x when our inverse is equal.